In this problem, a car enters a freeway with a speed of 6.5 meters per second and accelerates to a speed of 24 meters per second in 3.5 minutes. How far does the car travel during the period of acceleration? So once again, if we look at a problem, we always want to have an idea, a picture in our mind of what this looks like, and it helps to draw that picture on the page to identify what we have going on here. All right, so here's our car. It's moving down the freeway. All right, we can identify its starting position. I usually like to reference that as 0. And it has some velocity at the start. All right, so there's our 6.5 meters per second of velocity. We reference that as an arrow pointing in the direction that it's moving. Later, the car is going to be down the highway a little further at some final position. And that's what they want to know. We don't know our final position. What we do know is it's now traveling faster. So I'm going to draw a longer arrow. We'll learn that vectors, the length of the arrow, it corresponds to its magnitude. So a 24 meter per second arrow should be longer than a 6 meter per second. And technically, it'd be almost 4 times as long. This acceleration phase happens over a 3.5 minute window. And which way is it accelerating? Well, if it's gaining speed, it must be getting a push to the right. So I like to put the A arrow on the picture. It is also a vector quantity, which we'll talk about, but that tells me which way A is. And let's define our positive direction. Since all those arrows point to the right, it would make sense to call to the right positive. All right, and so now we can be consistent about our signs. So the next step is really to organize all these variables. I like to have an AT-VX table. AT, V initial, V final, X initial, and X final. Those are all the variables in our 2 kinematic equations that we have listed above. What we don't know is our acceleration. So I'll leave it blank. We have a time, 3.5 minutes. Now, hopefully you recognize, hey, that's minutes, and we have meters per second. So now we have mixed time units, seconds and minutes. So I'm going to recommend converting this right now from minutes to seconds. There are 60 seconds in 1 minute. Notice my minutes will cancel because they're on the opposite side. This will take it to seconds. And in my calculator, I can take 3.5 times 60, and now I have my time interval of 210 seconds. So we do our conversion right there in our table. My initial velocity, I start moving at 6.5 meters per second. Later, I'm going 24 meters per second. I start at a position of 0 or whatever I care about, and I'm going to finish some other position down the road, right? And they want to know how far. How far would be a displacement, which is just x final minus x initial, which when x initial is 0, we just get x final, right? So really, if they say how far, by calling x initial 0, when I find x final, I have my answer. All right, so where do we go from here? All right, well, we have our 2 kinematic equations. We have x final is 1/2 at squared plus v initial t plus x initial. And we have our velocity function, v final is at plus v initial. And again, I like to put a little dot over everything I have. I have t, v initial, in the starting position. I have v final, v initial, time, and I'll put a question mark over the things I don't. All right, so immediately we want x final. There's only one equation with x final in it. X final is right here. However, I'm missing a in that equation, so I can't solve for it directly. However, if I look at my second equation, I notice that a is the only thing I don't know. So with that in mind, my first step is to use the v final equation to calculate or solve for the acceleration. So when I plug in, v final is 24 meters per second. That equals a times the 210 seconds that I converted plus the 6.5 meters per second. And it's an algebra problem to solve for a. We're going to subtract 6.5 meters per second from both sides. That's going to go away. 24 minus 6.5 gives us 17.5 meters per second, and that has to equal A times 210 seconds. And so I'm going to divide by 210 seconds. On both sides, and we see we get meters per second. And when I take 17.5 divided by 210, I get 0.083. A is equal to 0.083, and I'm going to take it to 3 significant digits. That's going to help me when we work on WebAssign problems, just in case there are rounding errors. So I'm just going to keep it as 3 significant digits. In my calculator, I actually have the full version. I'll use that when I do my calculation. So now that we have A, we're going to use the A value to calculate X final. And so I have everything I need. I'm just going to take my values above. X final is equal to 1/2 of that A value, 0.0833 meters per second squared, times my time, 210 seconds, and that is squared, plus my initial velocity, which is 6.5 meters per second, times the 210 seconds, plus my initial position, which is 0 meters. And again, I put the units in there to show you that seconds, that's going to get squared to both. So seconds squared will cancel with seconds squared, and I'll get meters. Seconds and seconds will cancel, I'll get meters. And I already have meters, so I should get an answer at the end that's in meters, which is what I want for a position. So again, the units are always going to work out as long as I get everything to meters and seconds before I do any calculations. And so now I just got to plug in. I'm going to say 1/2 of that answer, second answer, that way I don't have to round. It's going to carry all those 3's in there, times 210 squared time, plus 6.5 times 210 seconds. And I get 3202.5 as the final position. 3202.5 meters as my final position. All right, so let's think about that answer. Does that answer make sense? So about 3 kilometers. Now, this car is traveling for 3.5 minutes, and it's speeding up, right? So that actually should make sense, right? So, you know, some of you guys might want to convert to miles per hour to kind of get a ballpark idea, but at 6.5 meters per second for 100 seconds, you'll be going 600 meters. But again, at the end, I'm going 24 meters per second. So maybe my average velocity is somewhere in that 15 to 18 range, right? And if I multiply that times 210 seconds, that seems to bear out. So I believe that answer makes sense, about 3,202.5 meters.